Today I'm going to continue to work on the toy linker project of mine. Last time I finally got the first real program to link, namely this broke game. So if I go into that directory, I had this link, link.bat, which is just, well, it's calling the linker and apparently still has the debugger in front of it. And then it has all the object files. It specifies all the object files. First of all, let's maybe go into broke and remove the debugger so we can just test it out. Link.bat. Okay. Then if I call link here, it complains a lot about symbols being defined more than once, which we ignore. All of these symbols probably have the decker spec DLL select any, so, or the inline, external inline functions, in which case, well, we just pick any of them and it's fine. And so this is why it's complaining. Well, a more sophisticated linker would deduplicate these symbols, but we just emit all of them, and then whenever there's a relocation, we just pick any of them. Anyway, and so the idea, well, this compiles and we can run it. So I think I have to resize the terminal to make the game work. But this should have produced a a.exe, which you can see 212 is just now. And I can run this by running it. And then this is the broke game. And so this is all this is what's working right now. So there's one big hack in here, which last time I sort of said I would ignore entirely, but felt like I should address it today. And that is that currently in the linker, we have these DLL imports. So things from other DLLs that are imported. And currently all of these imports are just from 4 libraries, which I hard code right here. So loaded DLL, and this is, each of these DLLs has a name, and then I use load library of the DLL, and to get a handle, and in the end, right here, use get proc address to figure out in which of the libraries each DLL import is. This is obviously a complete hack. What we really would want to do is to parse .lib files. So if I go back, you can see in the command line, I only specify the obj files and not the .lib files. So the equivalent file for CL that I wrote is type, I think, builds cl.bat. Right, and there it, well, I don't have to specify all of the C files. I can do star.obj, which my linker currently doesn't support and never will. But then I also specify ucltlib, kernel32lib, user32lib, and add API 32lib. And so these are exactly the 3 DLLs that are specified right here. And so the goal for today is, instead of hard coding these DLLs right here, is to be able to pass in .lib files, restricted to, I assume every .lib file is just an import library, so just for resolving DLL imports. Because you can also pack together arbitrary obj files into a lib file to statically link against. I'm not going to support that. I'm only going to support .lib files, which are import libraries to interface with kernel functions. Okay. And, well, so I was kind of not going to do this because it's a little bit annoying, but I have already done it once for my compiler. So we're just going to get inspired by code I wrote before. Namely, if we go into the compiler source code, And let's maybe do it on a command line because I'm not quite sure in which file this is. So the headerless C compiler, if I can spell. And then we open another editor, and I think I always do font size 36, which I may have forgotten here. Yeah. Then what we want to find is where AR files are passed, because these library files are, well, of the AR format, archive format or whatever. And so I think it's parse AR file or something. Something AR. Library node. That probably brings us closer. Look, function in DLL imports, library node, libraries. Here we are pushing a library node and IR parse file. Okay, that's why I couldn't find it. It doesn't have a leading underscore. And well, removing this is sort of the function that does everything, that passes these files. And then down here we have the AR lookup symbol, which is looking up a function inside of one of these libraries. Okay, so I think I'm just gonna go do a quick little yoink and then close this. Then also I'm going to reopen this to get a larger font size. In the linker, add font size 36. Okay, beautiful. So as a reference, I'm just going to go into the scratch buffer where everything gets deleted in the end. I'm going to put in these functions. No, they don't have highlighting. Okay. Screw that idea. New AR.c. Put it in here. I'm going to delete the file later. And in the linker, we sort of have to do the equivalent thing that this does. So maybe to get a little bit acquainted with this file format, there's a section in the PE spec. But more or less how these work is that, well, it starts with a header, and then there's a sequence of file sections. Each of these file sections again has a header and then contains usually an object file, or it contains a stub object file to define one of these DLL imports. And so there are 3 special file sections on Microsoft AR.lib files, whatever. Namely, there's one called dash, and then there's a second one called also dash, I think. Yeah. And then there's a third optional section, which is called dash dash, which contains, like, is only a string table for longer object names. We will see what that means later. Okay, let's start writing an equivalent file here. And I think here it's called load object file, parse object file. Okay, so we are supposed to do something similar, but not object file, but I'm going to call it AR file. Maybe I should call it archive file. Archiver. Should I call it archiver or AR? Let's call it AR. So parse AR file. Correct? Yeah. And this may or may not have to return anything. This one returns an int. which is 0 if it didn't work and 1 if it worked. So let's do the same here. And well, we probably need the same also an object file thing. We don't know what that is though, but maybe let's call it struct AR file. Okay, so far so good. Now the first thing we do is load up the file, which in this code base I do prior to this in main. So right here I do push object file star for the amount of object files, which is just argc -1. This is going to change a little bit because now it's object files and AR files. So maybe let's just do union this. Okay. So more or less I want the exact same amount of pointers, but the first ones I think I will do object files, and then the later ones I will do AR files maybe. Oh, here I allocate them not by pointer, but by reference or whatever, by value. All right, let's maybe do the simpler thing, and this is an object file. We can do everything else later. Okay. And so because now we have the parse object file right here, it was loaded. We get the file name initialized, and we get the stream, which is the data, the size, and the offset. And then it calls parse object file here. So now instead, we want to see what the file extension is. And the way to do this, I think, is first off, we do a searcher. I think this is the correct function, but let's Google, which finds from the end of the string a character. Searcher function in C locates the last occurrence of a character in a string and returns a pointer to it. Okay. Extension is the searcher of the file name and a dot, and then if comp of extension and .obj, this is 0, then we pass an object file. Otherwise, if the extension is .lib, we pass an archive file. Let's put this down here, maybe. And then we're just going to print a bad error message in the case where it's neither, namely error parsing file. this is now parse AR file. So far so good. We have checked, we have tried to load it into the arena, we have checked that it exists. Now we have to first, okay, let's get this big, not in that direction. Parse AR file if how do we do this here? Stream. Okay, we have this stream peak, which doesn't increment. We have stream read, which increments. And we have also stream read range by pointer, which we might use right here. So if stream, so we have the, first off we check if it's $arch \n, then we increment, and then we pass linearly these AR file header. So we sort of just want to read this, I think. It's the easiest thing. So let's do a charm. What's that called? A signature? Maybe it's a signature. It's 8 bytes. And stream read of the stream, which is AR file stream. But I think I pulled it out here. Yeah, let's do it here as well. We read from the stream into the signature of 8 bytes. If this fails, return 0. And missing one paren. If the signature is also not $arch new line, and it's also a parse error. This one, file add is data +8, file end is data plus file size, sort of implicitly what we do with a stream. Here I just want for empty libraries. I'm not sure why I do that. But anyway, we get the AR file header, and I'm just going to copy this definition. Then I have a big endian symbol index space, a big endian symbol index size, a little endian symbol index space, little endian symbol index size, and a long name database and a long name data size. Don't think I care about the big endian stuff. But the way this works is, again, there are 3 special sections, which is the little endian, big endian symbol index, and then the long data section. And so, well, let's also maybe extract all of those. We iterate over the entire file. For, I guess, the way I'm going to do this here, because I'm using these stream abstractions, is I will just have this file header. So AR file header. And I'm going to use while I have this file header. So while we are able to read the stream into the AR file header for the size of the AR file header. While that succeeds, we now have this AR file header and we can use to parse it. And okay, we get a file identifier and a file size string. Yeah, because how this format works is there's a file identifier, which is going to be the object file. And then everything else, all the information about this object file is encoded in ASCII, which is great. So we have owner and group ID, which is Unix stuff, the file permissions, which is Unix stuff, and then we have the size, also encoded in binary ASCII, in ASCII decimal bytes. And then finally it ends with some characters as well. But what this means for us is we have to be able to parse this file size, which is a decimal thing, which I think we can just use like stir to long or something. But I don't know if this is zero terminated. Probably isn't. Anyway, yeah, and then I do string strip whitespace here because these the file identifier and the file size string, right, they are not zero terminated. Instead, they are terminated by a white space, so they're padded with white spaces. Okay. So we need a function like the string strip whitespace, maybe, and well, let's go stealing. Let's get inspired. String strip whitespace. Thank you very much. Love you. And I'm gonna put this close to the string stuff. So here's a string match, here's a string strip whitespace. Where am I? I am here, right. So we do string struct string file identifier. Well, let's just copy these lines actually. Whoop. And then the file header is by value. Beautiful. Now, we have to pass this file size, and let's see if there's like some stir n to ll. No, there's stir to ll, but I want one that's has a size parameter. It doesn't seem to be. Well, but Let's get hacky. This file identifier is terminated, or has white space at the end, so we can always overwrite the white space and we don't care. And after it comes this file modification timestamp. So we also don't care about that, so we can overwrite that. No one cares. And similar here, these ending characters we can also overwrite. And also the white space, obviously. So I'm just going to say arc. Actually, for the file identifier, we sort of don't need it. We overwrite the file header here to make sure it's the file size string. String is 0 terminated. So let's just do file size string dot data at file size string dot size is 0. And then we can do stir to ll, ll being long, and I think I actually want url because the file size shouldn't be negative, of the file size string data null. Null meaning that's in the end points to the end of what it parsed, but I'm going to ignore there being like an invalid file size that doesn't only contain the decimal characters, and the base is 10. So U64 file size. I'm going to ignore errors. Very nice. Though maybe I could check for -1. I think that's what it returns. Stir to UA. Returns 0 if no conversion can be performed. Returns the converted value, if any, or u long max on overflow. Returns 0 if no conversion can be performed. Sure. So u long max, I think is the case I maybe want to concern myself with is -1 from 0. Okay. Each data section has 2-byte alignment. So here, oh, that's right. I have to skip the size in the stream if I don't want to pass it right here, which this code doesn't. So maybe I don't. Then file at is equivalent to stream skip, I think. This is taking the stream and the size, which is the file size. Great. File size and plus the file size and 1. Let's copy this comment. Each data section has 2-byte alignment. Okay. Okay, sure. This I think we can all copy. In the end, a break. Oh, I see. So after this, I loop once for the first file header, which is dash, which is the big endian symbol index. Then once for the second dash file identifier, which should be the second linker member, which is a Microsoft specific thing that there's a little endian symbol index. And then if there are longer strings than I think 16 bytes or something, they have to be optionally in this long name data section, which has the name dash dash. Okay. So, and we assume there is a little endian symbol index. Okay. Otherwise, we are saying this did work. It's supposed to have a file name, so let's get that one out. Is AR file, then it's file name or just name? I think file name probably. Let's just go with that, and it's gonna yell at us later if it's wrong. Okay, so the second linker member or Microsoft specific symbol index has the following layout: amount of members, member offsets for amount of members, the amount of symbols, then a symbol member index for the amount of symbol, and finally a string table for amount of symbols, many zero terminated string. And the algorithm to search up something is we binary search the string table for whatever we want to look up. This gives us a symbol index. The symbol index we put into the symbol member index thing. And then we can use this index in the member offsets to get the member offset. And this member offset then points to a AR file header, if I remember correctly, of the object file that symbol is in. Yeah, right here. Then we have the AR file header is the file header of the file data, which is the data of the object of the library file plus the member offset. And then we can pass the object file or import header. And we are only going to care about import headers. Okay. Let's copy this comment because it's very nice. And make sure the symbol index can contain the amount of members. And the string table is zero terminated. So these are just some sanity checks, which I'm going to copy. If the size smaller than 4, return 0. If the symbol index base from the size -1 it's non-zero, that means, well, the string table, the very end of it, is not zero terminated, which is wrong. Okay, we have a symbol index at, which starts at the base and an end. Okay, the amount of members should be the first thing in this little endian symbol index. Actually, what I'm going to do is I'm going to make all of these streams. Big Indian symbol index, and then the little Indian symbol index, this maybe, and finally the long name data. Then we have to go in here and make these streams instead. So this is stream, and then I think it's .data probably, and .size is the file size. And same for the little Indian symbol index. And finally the long name data. Okay. So good so far. Now we can use the stream read thing. Which I think is what I do usually. Okay, let's just do it. Amount of members is stream if stream read of the this is now a size, and I don't need this anymore. Oh, base. So if the base of the size -1 is non-zero, then the string table is not zero terminated. Ensure the string table is zero terminated. So the little Indian symbol index, we read the amount of members for the size of amount of members. And we have the U32 member offsets is stream, I think stream read by pointer existed. Stream read array by pointer. And from the little Indian symbol index, the member size is size of U32, and the count is amount of members. It's kind of counting. What is going on? Where is a paren missing? What? Is that already too many, maybe? Yeah. Okay. If we couldn't get the member offsets, then we return 0. Then we have the amount of symbols, which is same as this. We do the same thing again, sort of. But this time amount of symbols. Actually, let's do a replace in range of members, or member to symbol, and then the symbol indices are U16s. So this one has to be a U16, and the size we assign here also has to be a U16. Okay. And finally, we have the string buffer. And that is just the end of the stream, so where we currently at variable stream current, because I have a stream peak. No, that copies. Stream range by pointers, maybe what I want. Of the stream. Oh no, that one takes a range. It doesn't care about overflow, that's great. This is probably the function I should have used here. Well, this one works because I used the stream skip thing. Actually, can this one fail? Yes. Okay. Actually, technically, this one can overflow, right? Okay. Anyway, we get the string buffer. Is the plan. And so we do read array by pointer. That's what I decided now. Maybe. Let's just do it manually. So we have the stream, and we can just say the string buffer is the little endian symbol index data plus the symbol index offset. We have ensured that this is zero terminated. Okay. Now what I do here is I linearly allocate a string table for all the DLL import strings symbols. In the end, I have a library node where I put all of the members I collected into. Okay. So I want to do something similar here. Can I allocate in here? Probably need an arena if I can, but I think I can. I have this arena and nothing's currently happening with it, so I can simply pass the arena here. and everything is fine. So we do something similar that we do here. We have the string buffer. We start daisy chaining the string table. So why is it an import table node? Shouldn't it be just a string? What else is in these import library nodes? Let's ask our trusty source code. 36. Import node. So these link back for some reason to the import nodes. Okay. I'm just going to ignore that. It's probably nothing I need here. So we just have a struct string. Maybe I could even use char star, but let's use string. String table is push array of into the arena, which we have not declared as a parameter, but here it is. And we put in a struct string .0 of them. And now amount of strings starts at 0, and then the SMN is just S64. Import symbol base. Because here into this table, I'm just going to allocate the import symbols and not care about the other symbols that are in here, which are in object files, which we could link to. Yeah. Again, this is sort of a hack, but it's currently what I do in my compiler, and it works mostly fine. Okay. So import symbol base is -1. Start at -1, so we can set it whenever we find the first --imp- symbol, because these symbols are ordered by name, so we can binary search over them, just one part of the step of the algorithm. So these strings are ordered by name, which means all of the ones that start with --imp- are sort of right next to each other. And so we're going to use this to find the first and the last of all of those. Okay, so right, we have for U8. Maybe I should use char here. I think that's probably a little bit more correct, because all of these are C strings. Char it is string buffer. We start at the base of the string buffer, while it is smaller than the end of the string buffer, which here I have a variable symbol index end. So maybe let's do char string buffer end is the base of the symbol, little endian symbol index plus the size of the little endian symbol index. Okay. Well, this is smaller than the string buffer end. And then we iterate it plus equal stir len of it plus 1. And yes, I'm just going to use char star here instead of string. So if stir and comp of it and dash dash imp dash for 4, no 5, right? Wait, even more, 6. Is 0, then we run an import symbol. We say if we haven't found the import symbol base yet, we set it. Amount of strings, sure. Otherwise, we push one of these char stars. Char star symbol is push struct to the arena. Wait, no, we have to, this is why I used strings there, I think, because this gets a little bit confusing, because we want to allocate one entry in this array. So we have to allocate the entries. So actually what we have to allocate here is a char star star, because we allocate a char star, and this is a pointer to the entry then. Maybe the way to do that without getting too confusing here is just to use and immediately assign it. So into the arena, we allocate a char star, and we set this char star to it plus 6. Skip the dash dash imp dash. Maybe call it skip ping. Yeah. So and then in the end, we also have to increment the amount of strings. Right, and so the amount of strings is not the amount of strings that we allocated in the string table right here, because we only have the DLL imports in the string table, but the actual amount of strings in the string buffer. Okay, now if the amount of strings is unequal to the amount of symbols, then we return 0. This is sort of checking for a corrupted file, which maybe we don't really care about, but whatever. So, amount of import symbols is push data. Oh, this is just getting the size, which if we using this daisy chaining approach, we have to push one more of 0 size and then just subtract the base. Okay, and then here in the very end, we initialize the library node. With all of the good stuff. Okay, so I am just going to put this essentially into the object file struct that I have right here. And how am I going to do this? Maybe just an int is library file is IR. Like the way I would like to do this is to have two different file structures. So let's do it that way. So in main, the other main, right here where I allocate all of these. But the way I do it here, this all kind of sucks. Okay, whatever. Let's not get bogged down by it, and just, we have this beautiful boy here, and we say these are object file members. And we have these are AR file members. Maybe let's use a double colon instead of just a colon. And then we say int is AR file. Okay. So what do we need? We need amount of members, which is a U32. We need the amount of symbols, which is also U32. We need the member offsets. So this is U32 star member offsets. We need U16 star symbol member indices. We need import symbol string table. So this is char star star import symbol string table. Sure. We need the amount of import symbols. Which we could know is a U32. Yeah, so we could know that both of these are U32s. Import symbol base. Because they are at most amount of symbols, because we have made sure that the amount of strings in the string buffer were equal to the amount of symbols. And this can only be true. And these are subsections of that. So the amount of import symbols is lower than the amount of symbols. And the import symbol base is also lower than the amount of symbols. Okay. So let's take all of these. And not in parse object file, but in parse AR file, we're going to fill these in. And these are in the AR file, which is object file apparently. Beautiful. And return 1 because we succeeded. Let's see if that compiles. Doesn't. Stream, object file stream, AR file. Syntax error struct missing semicolon. File header. It's called AR file header. File header index. Oh yeah, this was a for loop. in this one, right? So where's this? Oh, let's do the same thing we do here. So starting at 0, and then incrementing it. And we know that can only do at most 3 iterations. So 1 for 0, 1 for 1, and then 1 for 2. String. Did I not make that macro here? I thought I did. Oh, are we... Is there string stuff later on in the file, I assume? Well, it can go all the way up top. Up top. Okay. Oop. Line string stuff. Let's do strings. This is sort of a string thing, but okay, let's ignore it. This is streams. Checked files. Alright, enough cleaning up. More compiling. File header is not known because it's AR file header. File header index. It still complains about for some reason. So Archer takes a character, not a string. Plus has to be of basic type, but type is right. What I want to do here is maybe use the stream substream thing. Stream range by pointer. Though I think I've already made sure that that's okay, so I don't need to recheck that. So from the stream, well, I also don't really have the offset. Start and size and count. Also not great. Okay. So what we are at file add sort of right here. Here the stream is at. Maybe stream read array by pointer. Also not really it. Okay, actually this also gets rid of the overflow things. So, file data, is that a good name? Sure. We read an array by pointer. We need the stream, where we're currently at. We need the size, which is the file size. Oh no, the member size, which is 1, because we want it in bytes, and then the file size. And then we also skip 1 byte right here. if the file size is 1. So stream skip. Let's make sure that does not complain about size of 0. It doesn't. So if that doesn't work, or the file data is not there, then return 0. And then here, wherever I do AR file header +1, use the file data. And this is now nice and symmetrical. Data is file data, size is file size. That's nice. Little Indian symbol index base. So this could not be set if there was no such symbol index. Base, it's called data, not base. Data, could make it a union, but whatever. Member offsets undeclared. What was I calling it? Member offset. I like the member offsets better. Symbol member indices. Symbol offsets. No, this is not symbol offsets, right? I called it symbol member indices right here, so I should use that name. Import symbol string table. I think I just called this string table right here. So let's use the more verbose name. It's always good. Then that should compile. No, it complains about Archer not being in any of the imported DLLs. Which is essentially the problem we're also dealing with, but right, does that mean it's not in UCRT? Probably means that, doesn't it? Okay, let's go. Implementation and see. So this is literally going to be the GCC one, which is probably going to be horrible. Actually, this one looks okay. Oh, it's the chur, not the archer. All right, I'm just going to do it myself. Actually, this is really annoying. The problems of using your own code. Okay, I'm just going to rename it and first off, does something like this exist? No. Archer MSDN. Which versions do you have? Multi-byte ones. How do they look? Let's see if that one works. Hey, that one works. Okay, we're down to warnings. Local variable is never read, only written. Yeah. Yeah. Sure, let's comment them out. Actually, I need the long name data. That one I don't get why this code isn't using them. Is it? Did I just miss that? No. Oh, I think it's the long name data thing is only for the big endian symbol index, which is not the C one. Not the Unix one. Okay, big endian symbol index, not used, sure. Long name data is not used, sure. Wanted char given unsigned char. Okay, now, obviously, right now this isn't going to do much. It's going to be actually crashing probably if I run this, because it expects all of these to be object files, which some of them aren't. So I'm just going to parse all of them and see if that works or not. Then I'm going to return 0 right here. Okay, let's go into the linker directory and then to the broke CE directory, and here in the linker script, which actually I should edit here. I want to add the library files. So from the library files, which previously were in the, which are also in this build CE file. So new build CL file. So link.exe also takes the ucrt.lib, kernel32.lib, user32.lib, and adp32.lib. Okay, so link could not open ucrt.lib. That makes sense because these are, we need the lib path. Ugh. Well, that makes it kind of worse than what I wanted. Ugh. But that makes sense. Can't find these, and these are also not in the path, I think. So that makes all of that way more annoying. I thought it would just work, but that makes sense. So what I'm going to do is pass them all by full path. And these are in Windows kits, 10 lib maybe, this guy, ucrt, x64, ucrt.lib. This one looks correct. I want the path to this. There's no copy path option. All right, we're going to copy this. Link.bat. Now, kernel32, where could that be? Instead of ucrt, I think it's for user mode, x64, and then there should be kernel32. Yeah, I think the rest of them are in here. error parsing object file, uscrt.lib, which is the first one. So let's see what's going wrong. Remedy dbg. Okay. We're loading the file, getting the extension. Let's see if the thing worked. .lib, that seems alright. We are parsing the AR file. That's good. Reading the signature, and the signature is wrong. Why is the signature wrong? Well, we didn't get very far, did we? Not sure. Exclamation line, arc. I guess. Sure, let's do db then, because it is exclamation mark arc, as I would expect. And then there's the new line. Oh, are these not 8 characters? 2, 3, 4, 5, 6, 7, 8. These are 8 characters. Oh, if it's equal to 0, I return 0. That makes sense. So if it's a valid file, I return 0. Otherwise, I don't. It's not what I wanted to do. Not AR, but linker. Parse AR file. If the signature is not arc, we return. Okay. Are we doing better now? Fail to parse library, so we don't return. Currently only Windows-style import libraries are supported. First off, let's fix that we don't return if we fail. So in main, oh, do I return the wrong thing? It's supposed to return success. Yeah, this one right here worked the other way around probably. I just put the wrong thing in here, either way. And we don't get a little Indian symbol index. So let's go back to this and see what's happening. So we are loading the file, get the extension, we are parsing an AR file. And immediately this one is exiting out. Stream read. Oh, because this one returns 1 if it failed, so. While this does not fail. Sure. Okay, exit code 0. That's good. If I do all of them. Yeah, this is not doing all of them. Link is doing all of them. Exit code 0, which means that worked now. Okay. So toy linker doesn't need this incomplete. Now, the second function I copied is the function that actually looks them up. So it does a binary search over the import string table, which I've implemented manually here, which I guess I can use this code. And then I pass the AR import header. Then I have to allocate nodes. So all of this would happen, first of all, to make sure it all passes and doesn't work. What I would do is here where I get all the object file, where I get this array, I let's do something stupid like we have been. Instead of calling this amount of object files, I will call this amount of files, and we push amount of files object files and then amount of files AR files. And then I do split them. Check file. So we have this AR file, which is exactly the members used while passing the AR file. And just going to put the structure right before pass AR file again, and then use, instead of object file here, struct AR file. And so then I move this object file, some of this code in here, and I'll copy it. And here we use AR file. As this goes over the amount of files. We load up the file, get the extension. If it's obj, we make an object file, assign it, and finally put it into the object files array of amount of object files ++. Here we do the same thing, but it's not an object file anymore, but an AR file. And then AR files of amount of AR files ++ is the AR file. Amount of object files. Okay. Sure, we use this later on, but not anywhere before. So this should work again. None of the code should actually be running. Amount of object files, plural. It should work again. None of the code that we just wrote should actually do anything. It should execute because we are now parsing the AR files, but we don't yet use them to look up DLL imports. Somehow that seemed longer than usual, but I think it's the same as before. Then we can still execute it. All right. Come on, quit. Okay, whatever. It'll quit, hopefully. Right. And now when we are looking up these symbols, we don't want to have this loaded DLL here anymore. This should now go away. At least this handle member should go away when and instead we are supposed to look up these symbols that we couldn't resolve before that start with dash dash imp dash inside of one of these libraries that we just parsed. Okay. So here we make sure the string is 0 terminated, so the name of the symbol. And then we try to find a DLL which contains the symbol. So we iterate over all of the DLLs that we know of. Call get proc on the address on them, and if we could find the symbol, then we get out the DLL and all of this should stay the same. And so the thing that should change is this get proc address loop. And instead, what we want to do is iterate all of the libraries let's call it AR index 0, AR index is smaller than amount of AR files, AR index plus plus. We want to get the AR files, so in linker AR files, right? AR files of AR index. This is our AR file, AR. And then how should this work? We have to look up this symbol in the AR file. So the 0 terminated string we get out of the name that we have right here, but we add the size of dash dash in dash -1. So C string symbol name is the symbol name the data plus this. And then well, in the scratch buffer, we had this. Did I delete all of this? Oh, it wasn't in. I put it into the AR file, so we get his syntax highlighting. I want something similar to this AR lookup symbol. So let's do that. Here I need to see if here we can allocate into arena, but I think we can. We just built this hash table and we're done with this hash table, but we have not yet started to daisy chain anything else into the arena. So we can just pass it here as well. And possibly we need to pass at this loaded DLL because we want to only reference each DLL once and allocate a loaded DLL for it, which I think has to happen in this AR lookup symbol because it references multiple DLLs. Okay. Sure. So the arguments are sort of going to be the same, and then let's call this DLL import node because that's what it's called on the other side. And this one is gone. Okay. And so, yeah, AR lookup symbol, we allocate stuff in the arena. We pass in the AR, which here is called the library node, and then we pass in the C string symbol name. Okay. And this is supposed to return us one of these DLLs. This and if DLL break. So let's move this one out as well, so we don't compute it every time. All right, so we iterate over all the libraries, all the lib files. We try to look up the symbol, and if we could, this AR lookup symbol is supposed to find or allocate one of these DLL import nodes and return it to us. So we do probably need these DLL import nodes and chain them somewhere. Here, the way this works, how does this work here? I think it's globals, probably. Yeah, globals, DLLs. That's how this works, and this is a singly linked list. So I'm not going to make this global in this case, but this is just going to have a next pointer. And then the DLLs is not an array anymore, but oh well, we have this DLL import node thing, and then we have struct DLLs. And this is 0, and it starts out with a struct DLL import node first and last. Okay. If I want to pass it to the function, it kind of needs a name. Actually, maybe it doesn't. Okay. Anyway, so this AR lookup symbol also needs a reference to the DLLs. Okay, So let's try to write this function AR lookup symbols. Symbol name, let's put it here. DLL import node AR lookup symbol. I forgot all the arguments, but it had like the DLLs, so struct DLL, let's call it DLL list, list, DLL list. It had the struct memory arena, then the library node, which is an AR file, and finally the name of the symbol. Okay. Now this explains the algorithm again. So let's put this right here. And so we have to binary search the import string table. And I think there's a binary search function. Bsearch. So what bsearch, I consent. Bsearch does is, well, it gets a key, a base, a number of items, a size, and a comparison function. So I think all we have to do is take this, and do char star star. Found is, we get bsearch of the key, which the key is the symbol name. I'm a little confused. I think it's this. Then the base is the string table. So AR file import string table. The size is one of the members of the string table. So this shouldn't be an address, right? Should just be this. And wait, first the number of items, which is amount of import strings symbols, amount of import symbols. And lastly, the comparison function, which I think is just strcomp. Okay. And yeah, this gives us a pointer to the string we found, which we can get the index by, which we need right here, by just taking, subtracting the base. So symbol index is u32 of found minus the base of the import symbol string table. Then we know that this is smaller than the symbol member, but we know that this has amount of symbol members, so this can never be out of bounds. So this is the member index, AR file, symbol member indices from the symbol index we just calculated. But this member index we have not yet checked. So let's check that. If member index is bigger than, or member index -1, because this is what I'm calculating right here, is bigger than the amount of members, then well, this returns 0 because it couldn't find it. This means, in fact, that this library was corrupted or something. But we just say, in this case, couldn't find it. Okay, so we can then get the member offset by indexing the last array, the member offset array. Okay. Now, this will lead us to an AR file header. So, here in this version, I wrote this whole structure again, which maybe in this version I'm not going to. I'm just going to yoink it out. Put it right here. But then I can use the lovely stream function to get a range. So stream read range by pointer, which takes the stream. It takes the start, which is this member offset, the size, which is the size of the AR file header, and the count is 1. And we get out the struct AR file header. And if we don't get this file header, return 0. And the stream is file, AR file, stream. Okay, so at this point we assume we have this file header. We again need to get the name and the size, which I'm going to copy from our version here. So linker, we need to go into AR parse file. And here we AR parse file in the linker. Parse AR file in the linker. Right. The identifier is strip white space. And the size in bytes string is the same. Then we again use this hack. Maybe you should rewrite in the thing. Nah. We just assume none of these. If this is wrong, yeah, it's all fine. We get out the file size. And we get the file data. actually this is going to look different from here, because yeah, we just need this AR import header, which is at file header +1. Maybe I shouldn't pass that manually, but we'll see. We get out the DLL name, I think. Yeah, DLL name is apparently the library name, I call it here. Import header +1 plus identifier size +1. Let's try to understand that. Okay, so here this is just parsing the file size and making sure it fits. So this import header, let's use sure, that's at file header +1. Yeah, I'm not sure. But that's fine, maybe. Let's just check that the file size, that we can get the file size file data. Let's get out the file data just like we did here. I think that might be easier. But in this case, we don't want the read array by pointer, but we want the read range. Because we can just pass to it the stream. The start is it's member offset plus the size of the file header. Then we get out the file size. Okay, that's the file data. So then this is just the file data. And we check if the file data is there. Otherwise we return 0. Maybe here we should also check if the file size is smaller than the size of an AR of the import header. And we also return 0. Okay. All this checking. And here, there's also the identifier size, which I'm not quite sure how that works. I think it's the import header, the file data, file size -1 should be 0. So I assume the way this seems to me, there's not a comment, but it's the layout from the code that I wrote there. The layout seems to be that there is an AR import header. Then there is the identifier again, which the identifier is just a file identifier, I'm pretty sure. Oh no, the identifier is what I'm looking up right now. Okay. So the layout is import header. Followed by the identifier. Symbol. And then the last thing there is the DLL name. And so let's see that the file size, if it's smaller than an import header, that's bad. And also if the file data of file size -1 is not equal to 0. Because apparently it should be the import header, the identifier, and then the DLL size. So then we also need to check when we get this identifier. So the identifier is at the import header +1. So the char DLL name is at identifier plus the strlen of the identifier +1. So if the DLL name is the file data was bigger or equal to the file data plus the file size, then we return 0. This means if this happens, I think it can only be equal, but that means that they tricked us with the first 0 terminator. Okay, so now we have the DLL name. And so we are going to iterate these DLLs. That we have collected in the list already, one by one. For struct DLL import node, it is the DLL list first, while we still have one, and it is it next. We are going to check if we already have a DLL of the same name. So if it name strcomp and DLL name is 0, then what this is doing is it's breaking and having this DLL node. Sure, but this is using like import name and ordinal hint. This is doing some more stuff, which I don't care about. I think here, if I ever find it, I can just return it. But otherwise, if we haven't found it in the end, we need to allocate a new one. DLL import node. Node is push data, push struct into the arena of one of these guys, and it should be DLL import node. What's in there? So we have the next pointer, which we are going to initialize in the end. We have the name. We have the import index, which should be 0 initialized. And finally, the rest of these are going to be initialized later. So So we only need to care about the node name, which is the DLL name, and then the DLL index is 0 initialized. These guys are 0 initialized. So we're just going to say the next pointer. We're just going to chain this node onto the end of the list, or the beginning. Let's do, probably if we just pushed one in, likely the next one is at the start, like we want it to be at the start. So let's do the start. So if there's already something in the list, so DLL list first, then we say node next is DLL list first, and DLL list first is node else. So in this case, there is nothing on the list yet. So we just say DLL list first is the same as DLL list last, namely node. Okay, so these should chain all of the DLL imports onto the list. Finally, I think I might need the amount of things that are on the list. So I'm also introduce that member. So use 64. Size. Okay. Almost done, almost done, almost done. DLL list size plus equals 1. So these don't have an AR file header because here it's just called file header. So let's call it AR file header. Stream read by pointer to your arguments to function. 1. Yeah, it's the size and then the count, which, I mean, maybe 1 file size is more correct, but it doesn't matter really. Okay. Wanted char given unsigned char. I can change that. Loaded DLL doesn't exist anymore because it's now DLL import node. Wanted, give me that, sure. Invalid dereference, right. Here, where we do the array count of DLLs, this is now instead the loop over. Okay, this one doesn't need the size, it just needs to be a loop over all of the DLL import nodes. So the sort of one of these, it is DLLs.first, it, and it is it next. And then we have it name and it DLL import index. So here array count of DLLs. Here we actually need the size. So just DLLs size. Here we also need the size, so DLL size. Yeah, we also need the size, so right. Here, on the other hand, we don't need the size, but we need to iterate over all of them again. So let's find the loop. Does that? Maybe here I don't call it just it, but like DLL maybe. Import table base DLL index. Oh. Maybe I do need the DLL index, sure. I possibly just need both. Might be very possible. Because here I'm trying to fill them in. So let's put this into a nice loop because you can't have multiple types in a for loop, sadly. But we just do this is DLL is DLL's first. And then DLL is DLL next. Then we can do DLL like this. Okay, 2 more. All of these are easy. These are just DLL size. Okay, warning. Wanted CRT, core CRT, a secure search compare function. Which takes void. Yes. Actually, what I don't want here is not strcomp, but rather int strcomp wrapper, which takes a void star. A void star B, and both A and B are not char stars, but rather char pointer. So this is, I think, the correct typing. Then we return a strcomp of the actual values. So file identifier, local variable is never used. Is it never used in this version? Yes, I don't even get it out here, so sure, don't need this file identifier, I guess. Okay, that compiles. Let's see if it runs. Seems like it crashed, probably. Yeah. Not too surprising. But let's hope that's something rather easy. Then maybe it works afterwards. Yeah, I was kind of thinking it probably has to do with the bsearch. What is found? 0. Oh, that makes sense. We didn't find it. My confidence in this bsearch thing is still not that great, but that was definitely a bug. Halted with exit code 1. Ugh. Sure, I need to remove from the link.bat. Debugger again. Error. It's not known in any of the. It's not any of the known DLLs. Just now a very wrong error message, but I think every import is not known anymore. So let's see. If I do a link and go into AR lookup symbol, I think it's called. What is the problem? So we have symbol name, it's rename. We have AR file, import symbol string table. Sure, that's something. It's concerning to me that it starts with an underscore, but I'm just going to assume that's still fine. And yeah, I guess I want to look into this Stircom wrapper. So not step into, step over. Yeah, I want a breakpoint here. Do they look fine? So underscore A, underscore B. These look fine. Oh, probably found the thing. It's more than I expected. All right, the bsearch seems to work actually. Let's check that it returns the correct thing. Found returns a pointer to rename. That's also fine. Then the symbol index. Something fairly low. The member index. Seems also fine. Get the member offset. Which is maybe fine. No. This member offset is wrong. So where do I assign the member offsets? I here say that they are U32s, which is what I claim here, for amount of members. Let's see what the code in my compiler does. So the member offsets is library node member offsets member index. And member index is minus equals 1, yeah. The symbol member indices of the symbol index. Wait, the member index was wrong, right? Let's look at this again. the member index wrong, or was the... Ugh. Okay, let's do it again. So we get the symbol index, we get the member index. Okay, the member index is fine. Maybe, probably, likely. But then we get the member offset. This one is way too big. So something's going wrong there. So most of these look fine. We are looking for 528. So these are just linearly going up as I would expect them to. And then 528. Are we running into a bug in my compiler? Because this seems to suggest that this member offset should be this value right here. Like, oh, maybe it is. Yeah, likely it is. I didn't look at this in hex. Let's open watch window 2. More watch 2. $29,804. Nope, that's not it. What? But if I look at, are there two member indices or something? What is going on? Am I dumb? Symbol index, member index. 529. Wait, 27, right? 527 should be the thing. Yeah. Oh, these are in hex. Sure, what is 527 in hex? 20F. So it's way further down. That's why I was confused. Okay, that specifies that value. And it says that in this stream at member offset, this does not have that much data, right? The stream starts at data and has this many bytes. Which that number should exceed this number. So we calculate the end. Which this number also does not exceed the size. So if start is bigger than stream size or the end is bigger than stream size, return 0. Oh, no, wait. Do we have a file header? Yes. Oh, did I? This one cost me way too much time. Holy crap. Yes, if I don't have an AR header, I want to return. Thank you. Okay. Let's change link again. Imp memmove is not in any of the known DLLs. But that might be all of it. Why is memmove not in any of these DLLs? And why is that not a problem for MSVC? Did I get all of the libraries? At whatever, user 32, 1, 2, 3, 4. Yes, I did. So in which DLL is memmove if I look at the binary compiled with MSVC? So this is broke.exe. This is the one compiled with MSVC or linked with link.exe, I guess. So dump bin slash imports broke.exe. Man, I don't know why the console is so slow today. And I assume it's somewhere in this. Where is he? This one does not have memmove. Calloc free malloc. No memmove. Remove. Okay. So I guess because I am not good about minimizing imports, have to link to memmove, while they don't have to do that. I assume it's what's happening. Sadly, don't really know how to fix that right now. So I guess I'll hack it up for now. By doing the same thing I did with all of the other hacks. So there's somewhere in hack.obj. Here, where I replace all of the symbols to be in, which are not declared DLL import, to be declared DLL import. Here, I'm just going to write an implementation of memmove. Do I have one of those already? No. This is the signature, I guess, which I don't care about. Go away. And I guess I'm really assuming here that there isn't just a bug and memmove is exported by this might not even work what I'm doing right now. This won't work. All right, let's see how many instances use memmove actually. So here in this font size 36, let's look at the memmove. List all memmove. No one. These are, oh, I haven't loaded anything. Load recursive star.c, all the C files. Then search for memmove. Oh, I already have a hack in here. In pre-main, there's a declaration of memmove. Okay. Underscore memmove. Sure. Maybe that already exists. You can just go like this. This is underscore memmove in ars.c. I don't know if that's compiled into anything. Okay, does this still compile with MSVC? Build CL does that. Unresolved external symbol underscore memmove referenced in ddelch. So here I have this. This seems like a beautiful implementation of memmove. I'm just going to put this into, oh, this is the, okay, here, into hack. Okay. Right. I'm not sure this even links hack.obj. Does it have these hex symbols? Yeah. So it must. On the link line, it doesn't. Oh, because I built it. All right, I put it into this build directory. So the way I think this works is just cl-c -fo, or we want to compile hack.c into fo is build like this. Different const qualifiers, build cl. All right, that worked. rock.exe. Okay, that still works. Now using my hacky memmove instead. So let's see if that links with my linker. No, it crashes with my linker. Great. Okay. When it's trying to do DLL name Sterling. We have apparently 35 DLLs, and the DLL we're currently at is 0. So let's look at DLLs. These look fine. to me. This one has no name, which is a little bit weird. Okay, these are not 35. So what is going wrong? I should only be incrementing the size when I'm allocating a new one, right? Here I increment the size. This is when I allocated a new one here. So let's maybe look at all of the instances where this is happening. We want to go after the node is initialized. And I want to look at DLL list. So right now should be both pointing at the first one, which is math. You only get there once. Oh, I didn't set a breakpoint. Right, this is turning out way too long. But anyway, here we go. Both the first and last point to math. Next one. Now the first is adjusted. It's kernel 32 and points to the last one. Wait, now the first is math again. Oh. Wasn't the first one math? Wait. Or was I just tripping? No, the first one is math. So there is something wrong here. So the first one is the last one. So I guess I want to see when this one is written, because it should not be written anymore after we just initialized it. So break when value changes. Second, the last is already not. Didn't I change when value breaks? Oh, but I broke when the last one changes, which apparently didn't, but it got overwritten. Okay. Sure. It is math now. But we assume it gets overwritten, so let's break when the name changes. Chia. What am I smoking? Does only this one change? I guess this one's probably was math. Then it's now not math, but MB. Okay. So let's do that again. We want a break when this A changes. So send this one to memory window, not memory window. Let's add a watch is what I want to do. And then I guess we do some binary searching. This is like 20. Nope. Let's do 10. Nope. Let's do 15. Not 154. 15. Math. Okay, we're almost there. 16. I want to break when this address changes. Hey, processor breakpoint at this. Okay. And I guess I only care about 1 byte. DLL import index. So there's some sort of corruption going on here. We have this symbol. DLL import index. This one seems pretty big. This DLL is all messed up. Why is that? Or do we not ever return anything from this function? No. AR lookup symbol in the linker. Yeah, working with unfinished systems. They should have warned for not all return path, not all control path return a value, but my compiler doesn't implement that yet. So we didn't get a warning. We just returned whatever was an RAX. And it is really confusing when that happens. Anyway, let's see if that works. It returns 0. Can we run it? Nope. Couldn't execute the code because the DLL was not found that it needs. Okay. Imports a.exe. This one's probably it. ACRT IOB func. So there seems to be a thing. Okay, but let's see in which library this should have been, because we find one. So if, do I still have it? Yes. If the symbol name is this guy, so maybe put this right here. If stir comp of this is symbol name, then we want a debug break. Okay. Sure, we don't need these breakpoints anymore. me find the symbol. It should be in this import header. Sure. Get the identifier. Debug S. Something seems to go wrong here. Let's look at the call stack and make sure the symbol actually has the dash dash imp dash. Seems a little bit weird that it would have, but yeah, dash dash imp dash ACRT IOB func. What does which one should this be? Originally, so if I look at the broke.exe and then I go find it, it thinks it should be in this guy. So I assume there's somewhere is an off by one or something. Code data const ordinal name. Oh, is it one of this name type? Import header 0 ordinal. If this import header is even correct. Version, time date stamp, name type reserved. So I don't remember this stuff anymore particularly well. I was kind of hoping I didn't have to dig into this. But let's open wherever I put the spec link. Do I have it? Oh, I didn't copy the spec link, I guess. Where are we here? This is not the correct thing. It is AR parse file. Yeah. This guy right here. Yeah, first linker member, archive style, signature, sure. Archive member headers is exactly what I was talking about. First linker member, second linker member, long names linker member, import library format, import header. sig1 must be FFF, sig2 must be FFF. Which it's not, right? These are okay. Sadly, I'm sort of starting not to be able to think anymore. So I think I'm gonna call it quits here. And next time, I hope I will finish this. Maybe I'm gonna finish this off screen as well. We'll see. Anyway, we almost got it done. We're sort of parsing these files. Now it's just debugging why this one particularly member doesn't work. You can see everything else works. Like these look perfectly, no, that's the wrong one. But these look perfectly fine. So I guess maybe one hack that I could do just to see that everything else works is I'm gonna take whatever that was in, this guy right here, and right, this is the wrong one. Yeah, in linker, just gonna say if we don't have a name for the DLL, it's this guy. So in parse file. Not parse AR file, but look it up here, where I say the DLL name is this. It's going to say hack. Actually, I could just use this. If it's this symbol name, then the DLL name is this guy. Go and write the file. And then it works. Okay. It's a little bit disappointing that it didn't work 100%, but all but that one symbol works. So I'm going to call that success. And I hope you enjoyed this. Thank you for watching. I'm probably going to fix that bug, whatever it is, off screen. Then maybe see you next time.